Hi everyone. I am Dr. Dinesh Yankuru from Jawahar Navodaya Vidyalaya, Vadavadu, Kottayam, Kerala. Often many children come across with situations like identifying distance, displacement, speed, velocity, etc. Mine is a very humble attempt to make this concept very clear to the learners at an early level, that means at class 9 level. So let's see motion and its description. So this is the first part of my lesson. So basically, what is motion? When we can say that a body is moving? See this diagram, a car is moving, but where it is moving, where the car is moving? Is it moving for its own? Or is it moving with respect to its surroundings? See, this car is moving with respect to plants, road, buildings, etc. So when an object is moving or changes its position, see, the car is changing its position with respect to the plants, road, etc., trees, etc. So we can say that if an object changes its location, position with respect to something, with respect to its surroundings, we can say that those objects are in motion. If it is not changing its position, we say that it is in rest. Now this one, see this man, he is going to that particular end, coming back. Again he is starting from 0, going to 6 meters, coming back to 2 meters. Once again, starting from 0, going to 6 meters, coming back to 2 meters. So what is the resultant displacement for him? That means the difference between his initial position and final position. See this one. He is traveling 6 meters to right, coming back again 4 meters. Now the totally he is traveling some 10 meters. But what is his resultant displacement? That is only 2 meters to the right. So there is a confusing term. What is distance and what is displacement? So dear children, distance is nothing but the total path traveled by that particular object or a human being. He is traveling 6 to right, again coming back 2, that means 4, again coming back, total 10 meters he is traveling. But here the displacement is only 2 meters. So dear children, distance is the total path length and displacement is the difference between initial and final position. So we can say that the shortest distance between initial and final positions. That is the difference between distance and displacement. Now, in physics, basically quantities, physical quantities are classified into 2 categories. One is a vector quantity and second one is a scalar quantity. What are vector quantities and what are scalar quantities? It's again a confusing term in the early ages of studying especially physics. So it is a very simple term. Those quantities where we attach with certain direction, that means if a quantity is specified with a certain direction, such quantities are called vector quantities, and where the quantities are not specified with a particular direction, such quantities are called scalar quantities. See, a lot of examples are there for scalar quantities as well as vector quantities. See this one, length, area, volume, speed, mass, density, pressure, all these are examples of scalar quantities. Whereas vector quantities means displacement. Just now we have discussed. Displacement is the shortest path in a specified direction, that is a vector quantity. So vector quantities are specified with an arrow. This arrowhead indicates the direction, obviously. Arrowhead indicates the direction. And momentum is a vector quantity. Force, of course, force is a vector quantity. In which direction we are pulling or pushing an object, it's a vector quantity. Then lift, drag, thrust, weight, all these are vector quantities where we specify a particular direction for a physical quantity. So vectors and scalars. Vectors means quantities with direction. Scalars means quantities without direction. Now let's see. Once again, distance is a scalar quantity. Displacement is a vector quantity because it has a magnitude as well as a direction in the case of displacement. So distance traveled by a moving body cannot be zero, but the final displacement of a moving body can be zero. Dear learners, imagine that you are going to a shop. You are from your home to shop, maybe around 5 kilometers. You are going to the shop, buying some grocery and coming back. Going to the shop, you may cover 5 kilometers. Coming back again, you are covering 5 kilometers. So totally you are covering 10 kilometers. But what is the resultant displacement? From where you started? From where you started? From your home. Now where you are at your home. So what is the resultant displacement? Zero. So this is the difference between distance and displacement. Distance, sometimes it can be zero if you are not moving. If you are not at all going anywhere, distance is zero. But even if you are going somewhere, if you come back to the same position, then the distance will not be zero, but the displacement will be zero. Dear learners, please note the difference between distance and displacement. Then now my question is, will this displacement be greater than distance? Is it possible for the displacement to be greater than distance? No. How is it possible? Because displacement is the shortest path length. Shortest path length. So how it can be lesser than the distance traveled by the body? So displacement is always less than or equal to distance, and distance and displacement are equal when it is traveling in a straight line. If it is moving in a straight line, it is covering a certain path and it is keeping the same direction. So distance as well as displacement will be equal. Now let's see this one. Okay, now let's see this car. Let's see the condition of this car. So this car is moving. This car is moving with a constant speed. It's not at all changing the speed. It's moving with a constant speed. Okay. See the motion of the car. So constant speed without any brake. The driver is not at all applying any brake. Moving with a constant speed it is. So it is covering equal distances in equal intervals of time. This object is covering equal distances in equal intervals of time. Such kind of motion is called uniform motion. You see this graph? In 1 second it is covering 10 meters, 2 seconds it is covering 20 meters, 3 seconds it is covering 30 meters. That means in each second this car is covering 10 meters of distance. So it is covering equal distances in equal intervals of time. Such kind of motion is called uniform motion, my dear students. Uniform in the sense that equal in all intervals of time, it is covering equal distances. Such type of motion is called uniform motion. So what is an example of a uniform motion? The motion of a car in a straight line without changing any direction. If it is moving in a straight line, such type of motion is called uniform motion. Now what is non-uniform motion? See here in this case, this object, it is starting slowly, but it is speeding up. That means its velocity increases. Just like if a ball is dropped from a certain height. Initially it will be at zero velocity, but it will increase velocity. When it is coming down, when it is falling down, its velocity will be increased. At a constant rate, its velocity will be increased. So such type of motion where the velocity changes, velocity do not remain as a constant, where the velocity changes, such type of motion are called non-uniform motion. Okay, non-uniform motion. So if the velocity remains as a constant, it is called uniform motion. If the velocity is changing in the sense that it can speed up, at the same time it can slow down. Both are possible. Speeding up is possible, slowing down is possible. Both these two type of things will come under the category non-uniform motion. Okay. Now let's see speed, velocity and acceleration. What is speed, what is velocity and what is acceleration? See the first case, speed. Speed we know 40 km per hour. In our normal automobiles we have speed 40 km per hour. What does it mean? It covers 40 kilometers in 1 hour. That means distance covered in a specific time interval. The time interval normally we take seconds. Okay, so speed is distance travelled in 1 second. So here it is written as distance travelled, that is S divided by T. distance traveled divided by second time, that is called speed. So what will be the unit of speed? Unit of distance will be meters and unit of time will be seconds. So it will be meter per second. So now in the case of uniform speed, it will be traveling with uniform, that it will be covering equal distances in equal intervals of time. See, this graph is covering equal distances in equal intervals of time. Then it will have uniform speed. Speed will be same or constant throughout the motion. Then next concept is average speed. Often you may confuse with this term. What is the difference between uniform speed and average speed? Average speed. See, of course you have a car, you are driving 10 kilometers and the first 5 kilometers you are going very fast and the next 5 kilometers you are going bit slow. Depends on the traffic, some road work or some block, something is there. So you are traveling bit slow. So how do you calculate the average speed? The first kilometers you are going very fast. The second 5 kilometers bit slow. So how do you calculate the average speed? Here that technique adopted is, you cannot say that you are very fast or you are too slow. Okay, so you have to take the total distance, okay, total 10 kilometers divided by total time taken to cover that total 10 kilometers. So that is the average speed. Total distance divided by total time taken to cover that distance. That is called average speed. Now, velocity is distance divided by time. So velocity of the body. So of course, since it is a vector quantity, velocity is a vector quantity, we should always remember that we have to take the displacement divided by time. It is displacement divided by time. Velocity is displacement divided by time. Then velocity is often measured in meter per second. The base unit. Of course, we have different other units like kilometer per hour, kilometer per minute, like that. Different other units are also there for this velocity and speed. See, velocity and speed are same, but what is the difference? In velocity, we are attaching a specific direction. Velocity, we are attaching a specific direction, whereas speed, we do not attach any specific direction. The uniform velocity means it is going with the constant speed in a specific direction. Uniform means constant speed in a specific direction. That is the meaning of uniform velocity. How can we change the velocity of a body? It can be changed in two ways because it is a vector quantity. It has both magnitude as well as direction. It can be changed in two ways. What are the two ways? First one is by changing the speed of the body. By changing the speed, we can change the velocity. What is the second method? We can change the direction. We can change the direction because it is attached with magnitude as well as direction. So first one we can change the magnitude, that is the speed. Second one we can change the direction. So by changing either speed or direction, we can change the velocity of a body. So dear children, velocity is attached with two things. One is its magnitude, that is speed itself. Second one is in which direction it is moving, this body is moving. So either we can change the speed or we can change the direction. In these two ways we can change the velocity. See this graph. So it is increasing at a constant rate. Displacement is increasing at a constant rate. Okay. So this is an example of uniform velocity. It's an example of uniform velocity. Okay. Now you see this accelerator. In every vehicle there is a device called accelerator. Okay, so now see it is between 60 and 70. So at 65 it is get glued into 65. That means it is going with uniform velocity. Okay. Then here again it is increasing at a constant rate as well as decreasing at a constant rate. If it is going in a straight line, if the body is going in a straight line, its velocity. And if it is increasing its speed, its acceleration will be in the same direction. Okay, a car is going in a straight line in a specific direction, and its velocity increases, then velocity and acceleration will have same direction. Okay. Here now let us come to acceleration later. Now it's only beginning for the acceleration. Now what you have to remember here is, this is an example for uniform velocity. A car which is going in a straight line with the speed, fix the speed. That is an example of uniform velocity. Then average speed of a moving car or moving body can never be 0, but the average velocity of a body can be 0. Dear learners, tell me how it can happen, this equation. See this one. The average speed of a moving body can never be 0, but the average velocity of a body can be 0. See, remember this one? Moving. If it is rest, both are 0, but moving. So if average velocity of a moving body can be 0, but average speed is not 0. Tell me one situation like that. Okay, so if it is going and coming back, it is going to a certain point and coming back. So it is going with some speed, coming back with some speed. Total distance it covers. Time, some time interval has elapsed. So distance divided by time, speed is not 0. But what is the average velocity? Average velocity is the displacement divided by time. What is the net displacement? He went to that place, came back to the same place. Went to that place, came back to the same place. So the net displacement is obviously 0. So the average velocity, obviously it will be 0. Now, dear children, with this we conclude. What is the basic definition of acceleration? Acceleration, that means speeding up or slowing down. Change in velocity. The basic thing you have to remember in the case of acceleration is simply change in velocity. Wherever there is a change in velocity, the body is getting accelerated. Again, dear learners, change in velocity doesn't mean that always an increase or decrease of speed must be there. No need. A change in direction is also a change in velocity. Velocity means two things are there. One is its magnitude and second one is its direction. So either a change in the magnitude of velocity or a change in the direction of velocity will result in a change in velocity. So if there is a change in velocity, we can say that the body is having some acceleration. So acceleration can be of two types, positive, of course three types, positive, 0 and negative. If the velocity is increasing, see, if the velocity is increasing, we can say that it is positive acceleration. Velocity increases with respect to time, we say that positive acceleration. A speeding bus, speeding train, speeding motor vehicles are examples of positive acceleration. Then negative acceleration means slowing down, velocity keep on decreasing. Velocity go on decreasing. That is called negative acceleration. And what is zero acceleration? No change in velocity. The body goes in a straight line with constant velocity. That is called zero acceleration. So positive, zero and negative acceleration. These are the three types of acceleration. Hope my dear children you understood the difference between distance, displacement, velocity, speed, acceleration and its different types. Let's recap once again. Distance is a total path length and displacement is the shortest path. Speed is the total distance covered in unit time and velocity is the displacement in unit time. Okay? And displacement can be less than distance. Displacement can even be 0 even if there is a distance. So these are the things to be taken care. Then acceleration. Acceleration is the rate at which velocity changes. In 1 second, how much increase in velocity is there? How much the velocity increases or decreases, changes? How much the velocity changes in a second? That is called acceleration. Rate of change of velocity. Rate of change of velocity. Now, dear children, let us have a look into the units. Units. What will be the unit of speed? Of course, it is meter per second. What will be the unit of velocity? It is again meter per second. What will be the unit of acceleration? Acceleration is a rate of change of velocity. That is velocity divided by time. The unit of velocity is meter per second. So again, divided by time, it comes to meter per second square. So unit of distance is meter, unit of displacement is meter, unit of speed is meter per second, unit of velocity is meter per second, unit of acceleration is meter per second square, meter upon second square. Okay? Hope you enjoyed this small segment of lesson, my dear students. Hope to meet you next time. Have a nice time.